Well, I guess we'll talk about the spin indexer. Now, this was your average one until I modified it. So this head unit is flipped around backwards. If you go to Wood Creek Workshop, a guy there named Yule had a video called Flip It on how he took the nose of this, which is originally on this side, and he rotated it to put it on this side. It gives you more room, more clearance up here when you're working on something, which I thought was a pretty good idea. Now he put in some bearings in there, some thrust bearings. I didn't do that. But anyway, we're going to take this thing apart, find out what makes it work. So this piece in the back, this is just your shaft. Now the part that was on here, this part, this was that oblong looking thing with the little knob on it. You know, it's kind of like a, I don't know what you call it. It's not egg shaped, but it's kind of like that. You know, it's circular and then it comes down to a smaller diameter. It's got a little handle on it, and that's how you tighten this. And I wasn't really keen on that. And before that, I took these set screws, these three set screws that are in there, and I dug them deeper into this tube. And I sunk them in so that the set screws would almost come to the middle, but would stop, kind of like a counterbore. So the front of the set screw would go into this piece, but not through it, and it would act like a lock, so that when you were tightening or loosening this thing, the set screws wouldn't slip on this shaft because they were actually part of the shaft, kind of like little dowel pins that go in there. And I never really actually used this thing. I ended up building it, but I never actually used it to do anything with. Now hopefully after it's all built, I'll be able to try it out and do something with it. But I don't know, I had this idea and I just went with it and bought this and just started making modifications to it, and that's where I am now. Just modified it a lot. So anyway, we'll start with this part. So this was that piece, the stock piece with the three set screws in it. And what I did was I wanted to get rid of that oblong thing, and I wanted to put some kind of nut or something on the back of here so I could tighten it and loosen it. And I thought about using a small wrench, but then I would close off this opening, like have a plate with a nut welded on it and use that to open and close it. But if you had something long you wanted to stick through there, you couldn't do it because that would be in the way. So that wasn't going to work too well. So what I ended up doing was I was going to use a ER32 wrench, but that was too small for this. So I ended up using a ER40, and it's just a little bigger than the diameter of this, but it worked out good because these slots in here will fit the ER40. These holes in the top, they're just bolt holes that go from here to this piece. And then I put slots in here because I didn't want the bolts to take all the load, so I slotted it. And this little spot here, that's the original green piece. I didn't have to turn this all the way down. There was no need to. Just turn it down till it cleaned up, and then that was good enough. But we'll take this apart. Now I wanted to show you this. This is actually the drive gear here, and then it's bolted onto this adapter right here, which is then bolted onto this plate. Now this plate, the original one is steel, and we had to make this aluminum one for, we got another indexer like this at work, and we had to make this plate for a special job, which we never used. So rather than ruin the good steel one, I thought, well, let's use the aluminum one since it's scrap anyway for the job we never used it for, and just go with that. Then if something happens to it, it's not a big deal. But it ended up working out good for this job. Then this unit on top up here, that's the brake. It works kind of like a disc brake. This unit floats, and then it captures this disc, and it'll float. It doesn't pinch the back or it pinches the front. It pinches both of them, and it'll actually float depending on how it's set. You know, because you might be off a little bit one way or the other way, and because you didn't want it to hit against the back and then push it. So it captures that disc, and then there's room on both sides. So it'll squeeze it without putting pressure on either side of it. And then this piece up here is like a nose cone. This is where the collets go in. Then this is a guard to keep the chips out of the inside of here. Then I had to mount this ring on here so I could bolt this guard on here. And then this piece up here is a covering. The original, there's a hole up here where you have this knob. You tighten and loosen, and it cranks down on this shaft. And I was never really keen on that. It never really worked. At work, what we ended up doing was we had to put clamps on it. We clamped this piece to this piece with a C-clamp, and that's the only way we could really lock it down. because the pin they put in here, it doesn't go all the way through this aluminum piece. It's tapered. The front of that pin is tapered, so it only goes into the steel piece or the aluminum piece. It only goes in so far, and then it just sits there, and if it vibrates a little bit, it'll back off, and pretty soon this thing starts moving on you. So we ended up putting a C-clamp on it to keep the thing from moving. It was never really a very good idea, but with this brake system, that thing locks it down tight. And I take this screw out, and that gives me the hole that's originally there, and you can put oil in there to lube the shaft that goes through there. And what I did on the shaft that goes through here, I put a ball end mill down the length of the shaft, and then 2 circular rotations to keep lubrication on the shaft. And here I got 4 mounting holes on the outside, 2 on this side, 2 on the other side, and this is a dowel pin hole. I got a plate that this mounts to, and this keeps it aligned so that this pulley is aligned with the other pulley, so the belt doesn't track off of the pulley, because there's no guards on this, no shields on this belt. So anyway, let me put you up here and see about taking something apart here. So we'll put this aside, come over here and look at this. I put a mark on here because it's, when you drill these holes and tap them, it's a lot easier if you just line it up to the mark instead of seeing which one fits the best and having to keep rotate it and all that jazz. It's just a waste of time. So that just fits on there. It's got 3 kind of like keys. So this part fits the wrench. Actually, I have the wrench here. I made this wrench, I don't know how many years ago I made this wrench. It's like really old. This was flame cut. Wasn't even cut with a laser. It's kind of crude, sitting in the bottom of the box. And I thought, well, I could use that. So that fits on there like that. So I can rotate it. So I put these three keys in here, I guess you could call it. And I cut 3 in here so that this outer piece and this inner piece act as one. So the slot goes all the way through from the outer piece into the inner piece. So those keys help keep the inside shaft and the outside shaft as one. So what I ended up doing was, after I locked those screws down, I put that in the lathe, took a cut across here, just until it trued up. I don't know if you can still see that green. That's the original green. There was no point in taking that down. It just sits out in the air anyway. So I chucked that up, took a cut across here, got it true, took a face cut, and I took a face cut until I just hit this inner tube. I didn't really need to cut any off of it, but I just took enough so it just faced it off, so that I have a fairly true surface on this side. Then I couldn't get my tool back here, so I ended up chucking on this and then indicating it here. I didn't have to put a center on it, but I did take a cut on this piece here, not the undercut on the inside, not this piece, but this piece here I took a cut on. So then I chucked it up here. I got in here with a tool and I cleaned up this surface right here. So now all these surfaces are running true with this shaft. And then after I put this together, bolted it in. I took a cut across here and another cut on the outside so that all these surfaces are running true to the shaft. But that's that. So we'll put that aside. And now we'll look at this guy. So this thing here, gotta find the right one. I must have used it somewhere. Maybe this will work. No. Ah, this is it. So this is the outside of the brake. Now there's 4 springs in here. And what they do is they separate the brake, so when you release it, it separates off of the disc so it doesn't grab onto it. You got 4 springs in here. Now you can see, I don't know if you can see it, but they're different depths inside this plastic piece. These 2 on the outside are in further, so they don't have as much tension on them, and these 2 up here are out further, so they have more tension on them. Now these springs, I don't have a part number. I just grabbed some out of a box, but they're about 26 thousandths, 25 thousandths diameter, and it's a 280 diameter, and it's got a free length of 1 inch 400 thereabouts. And then compressed, I don't know, about a 1/2 inch compressed. But there's 4 of them. Now the springs are all the same, they're just different depths inside of this piece. So we'll take this guy off. Now this piece here, this is the outer piece. And I didn't want the aluminum riding on aluminum, so I made these little rubber, they're like rubber plugs. I had this this thing you use for notching out a belt. It's a round thing, and it kind of like got a taper on it, and then on the back it's got this tang, and you use it in leather for notching belts. And I used it on a 1/16 thick piece of rubber. I got a rubber sheet, and I cut these circles out. And what happens is that this 1/16 thick, I got this countersunk 250 diameter. It's going about 45 thousandths deep from the surface. So there's about 15 thousandths that sticks up here. And that's the squish factor that I'm using on this disc. Now I left this one out so you could see what it looked like. And I had to epoxy those in. You could probably use contact cement or something. Let's see if we can get this thing off. This is just the gear. Actually, this gear is part of this unit. Now this hole I got right here, I don't know if you can see that, but that's for this guy. So when I take the collet on or off, I put that in there, and I use this wrench and that wrench, and I can take it on and off. Of course, this rotates. You can use it on either side for when you're putting it on or taking it off. This is what I use on the on my you know, that square block and the hexagon block for you know, it's got a little 5C collet in it. But this is made by Armstrong, and it's a 3/4 to 2 inch 34-354 wrench. So that's what this little hole is for. So I could do that. At least that's the thinking behind it. But we can take this whole thing off here. Now this is a split collar. The original one I had look like this. I mean, it's didn't look very good. Yeah, it was a little messy. The holes were, the saw cut I put in there, the holes were hitting it, and got a hole there hitting that one. Couldn't put a hole there, and the hole here, and when I put the screw through here to tighten it, I couldn't put anything in here because it was just in the way, and it was just not well thought out. It was just wanted to try to make it work, but you know, that's how you try something and you make it work, and then you find out what is not working, and you got to figure out how to make it work, make it better, redesign it. Now I had to put this shim in here because when I flipped this nose piece was originally over here like an original one, and when I flipped it over, because I already had the bolts in the plate on the bottom and I couldn't move them easily, it threw the location of this off. So I had to make up this shim to make up the difference so that this pulley would still be in line with the other pulley, and that's what this little spacer plate is for. But anyway, this one is a lot better. A lot cleaner. The tightening hole is off to the side, away from all the other holes. It's a lot bigger too. I think I put a 312 diameter in there, 5/16 bolt. This one was a 1/4 I'm sure the 1/4 would have been sufficient, but it was just, I mean, it was just messed up. You know, with that hole being there, it just throws it all out of alignment, and it just looked bad. So anyway, I got this new one and I like it a lot better. And then this is the original ring on here. It's really nice because when you release this to take it off of the shaft, this won't release. I got 3 1/8 dowel pins in there, and I got corresponding holes in this piece here because when this is spinning, I got a washer back here, a brass washer, and I didn't want this. I wanted this to rotate on the brass washer, and I didn't want it to rotate on the aluminum. So I put these 3 pins in here so that it would keep it spinning from the back side, and that way this piece would hit against that brass washer. But it's it really, when I tighten this down to act like a clamping force, that piece falls right out. I'm really amazed at that. And when I release it, it's just enough tension to keep that piece from coming loose. This is the original ring that was on it. And I just drilled the 3 holes in there. Now see, it'll go in there. You have a little tension on it, and it moves. But as soon as you release that, it won't move. I tell you, could never do that again, huh? A little tension, it's free. You release it, can't get it off. I like that. So anyway, that's the lock ring. That fits on the shaft. Use that bolt, lock it down. That way, you know, you don't have any keyways in there. You don't mar up the shaft by putting set screws in it, this and that. So that works out pretty good. Alright, this piece, let's see if we can get this thing off. Well, we can take this off. Now this is held on by some bolts here. Yeah, this thing comes apart too. The bolts in the back hold that. This is the piston. This is actually the piston here. And then this is the cylinder. And this is an alignment rod. And this is just the air to activate the piston. Got an O-ring on it. We'll put that back together. Don't want to be losing that. See, both of those, without this piece on the front, those are able to move. This is the part that floats. See how that floats like that? So on the back of this piece here, you have the same set of 5 rubber pieces, and this floats. So we'll take this off here. I had to use these bolts. I had to take them down. Had to cut them back a little bit for clearance. They just fit through the holes in here. Of course, they got to line up. You have to drill holes in this piece. There's a lot to this little thing. It's not simple. See, I got the same rubber pieces here. There's one missing here, so you can see. So these holes here are drilled and tapped. This is clearance. This is clearance. That's clearance. It fits on there. Then these come off. Now these come off too. Originally I made these one piece, but I didn't have to. So now I made them 2-piece. And that's just a thread in there. That's a thread. Just a piece of round rod, and I put a thread on it. Little pilot on the end. That's so it hits the bottom, and it won't, you know, I didn't want to make the thread so that it was controlling the depth of the part. I put a pilot on the end with no thread, so it would hit the bottom all the time, so it would be a constant depth. I knew what the depth was all the time. When I screw it in there, the end of it's going to hit the bottom, so I know that this is a controlled depth here. And this piston got a bolt in it that screws into this piece here. You see how that moves back and forth. So this piece is bolted to here, and then this floats. I got these pins here. 1, 2, 3.